Welcome to my video. This video comprises several informations about normalizations. We have completed first NF, second NF. Now today we'll discuss about third NF, third normal form. So in first normal form we have seen the atomic value. Second normal form we have seen the primary key and dependency, that is all non-prime attributes should be fully dependent on primary key. And the third, today we'll discuss about third normal form, that is transitive relation. So before entering into this particular phase, we have to clear the concepts of transitive relations. Now in this particular slides you can see the relations, how we can prepare a transitive relations out of different attributes. So now what is transitive relation? You can see A to B here. So B is dependent on A, that's already is there. B is depends on A. And second we have B to C, that is C depends on B. So now it is a derived or it is inferred that A to C, that is C is dependent on A. So this particular relation or this particular dependency among the relations will find a derived dependence or derived dependency here. We are deriving out of two dependencies. One is A to B and second B to C. Then we can conclude A to C. So in this particular scenario you will find, so when we are taking A to B, that is B is dependent on A, B to C, C is dependent on A, it establishes a triangular dependency form. That's why we call it a transitive dependency or three ways dependency will find. For example, you will find beside example. So here simple examples we have given. Roll number to marks. That means marks is dependent on roll number. For example, one student is having roll number and he has scored 60% marks or 60 marks out of 100. So 60 marks is dependent on a particular roll number. So this indicates marks depends on roll number. And marks to grade. So when we are calculating grade, we have to see the marks. So ultimately we can conclude grade is dependent on marks. So out of this dependency we can derive a transitive dependency, that is roll number to grade. So now here you can find out roll number marks, marks grade, hence roll number to grade. This type of dependency we call it transitive dependency. And in third normal form we have to see that that type of transitive relation should not be there in the relation. We will see the definitions of third normal form. A relation is said to be in 3NF if it is already in second NF and there exists no transitive dependency in that relation. In other words, if a table contains transitive dependency, then it is not in 3NF. And the table must be decomposed to bring it into 3NF. So this is the definitions of third normal form, and this definitions has a transitive relation, so we have to see through some examples. Now I want to tell you, when we are going for third NF, sometimes you will have a branch of normalizations that we call BCNF. So now it's not next to after third NF then we will go for BCNF. It's not like that. It's a branch of third NF. We can split into a sub branch, that is we have to, sometimes we will have some cases that a relations may satisfy third NF and it can move to fourth NF, but there may be some problems or anomalies in that relations, and which can be included in BCNF, Boy's Code normal form. In this particular scenario you will find a relation is said to be in BCNF if and only if it is satisfied third NF, that means it must satisfy third NF, and the left hand side of every dependency is a candidate key. Here the concepts comes candidate key. What is candidate key? We'll see. A relation which is in third NF is almost always in BCNF. This could be same situations when a 3NF relation may not be in BCNF of the following conditions are found true. What are those conditions? You see, the candidate keys are composite. If we have a composite type of candidate keys, then these situations may arise. That means that 3NF or the relations which is satisfied 3NF, it must move to BCNF. Or there are more than one candidate keys in the relation. If any particular relations having more than one candidate keys, then that particular relations, though it satisfied the 3NF, but it must move to BCNF. Then third rule, we have to see the situations we have to see. There are some common attributes in the relation. There are some common attributes in the relation. If you have some common attributes in the relation, then that type of relation should move to BCNF to satisfy. So now in this particular case, at a time we can take an example here. Consider an example in BCNF. It assumes that a professor can work in more than one department. The percentage of time he spends in each department is given. Each department has only one head of the department. This is the figure we have designed, that this is department and professor code. We have combined it. This is called a composite key. Now department and professor, you can see head of the department is related to department. Percentage of time is related to professor or professor code. So a professor can spend a specific time, percentage of time, and a head of the department is directly related to department. But here we have combined or composite these attributes, and these attributes dependency here partially we have one dependency. It is not head of the department, it is not fully dependent on department and professor code. It is only department. Similarly, percentage of time is only dependent on professor code. It's not dependent on both these two. That's the problem. So once we'll make this is a primary key as a composite key, both these attributes should fully dependent on this composite key, not a single one or part of this one. Similarly, we'll find another instance here, department, head of the department, which is already I have explained, and here we can take another part, head of the department and professor code. We can combine one primary key here as a composite key. Department will have a head of the department link, and percentage of time will be in professor code. So similarly, the above case, you will have a similar case here. So once department is fully dependent on both these two, there should not be any problem. But department is fully dependent on head of the department, that's why it's a problem. So again, percentage of time is fully dependent on professor code only, not both these two. Again, this is problem. This is the scenario that particular relation should move to BCNF. This is how we can explain the dependency, and we have that dependency, we call it, here we have given in previous slides, we have, this is the situations, three situations we have. It must be a composite key, or it may have a several candidates key, or common attributes will be available in these relations. So these are the points which creates the situations so that a relation can move to 3NF to BCNF. And if we don't have these three points in our relation, there may not be chance to process the BCNF. We can move from third NF to directly fourth NF. So now we'll see the dependency here, third normal form, and we'll see here BCNF. Now at a time we can solve this particular example. Through example we can solve this. Here this is an example where we can find this. The normalizations of a relation is done by creating a new relations for department and head of the department, and deleting head of the department from the given relation. The relation normalized relations. The normalized relations are shown in the following list. So now this is our task which I have already discussed, and here you will find the example. Professor code P1, P2, 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 P3. Now P1 department, this professor code or professor belongs to physics department. This professor also teaches some maths, physics, both he has spent 50% of time. Now it is complete 100% he has spent. P2 chemistry department, 25% he spends the time in department of chemistry. P2 again physics department, 75%, and altogether you will have 100% he has spent. And P3 is only one department is associated, or this particular department he is working, and he is devoting 100% time to that particular single desk. Now in this scenario you will find that professor code, department, and percentage time. This type of dependency you will find percentage time to department and professor code, because we are taking as a composite key. So as I suggest that if we have our relation composite key, this is composite key, then we can go for BCNF. So now here simultaneously we are taking 3NF and BCNF, both the normalizations we are taking consider, because this type of situations comes. Now again you will see department, head of the department. Department, head of the department, single. So head of the department is dependent on department. So this is the scenario, and this scenario is associated with this example. So now you can see department, head of the department, dependency. Physics department, HOD is Ghosh. Mathematics department, Krishnan. And chemistry department, head is Rao. So in this particular scenario, you will find head of the department is fully dependent on department. Now how to split it to satisfy this normal form? We'll see later. Thank you.